going to take a look at factoring a greatest common factor, or GCF, from a polynomial. This is one of the first big steps in learning how to factor a polynomial, which is one of the biggest topics of the whole year in Algebra 1. So the first thing I want to talk about is what factoring is. So the word factor can take on a couple of forms. Factor could be a noun, and when it is, it means that it is a number or quantity that is a part of a product. For example, 3 is a factor of 39 since 3 times 13 equals 39. So 3 is part of a product. 13 also is a factor. What we're going to be learning to do is factor, and when I say that I mean it in the verb sense. And to factor in algebra means to rewrite a number or an expression as a set of factors. So essentially it's to rewrite an expression or number as a bunch of factors being multiplied. So for example, when I rewrote 39 as 3 times 13, I factored the number 39. In many ways, I like to think of factoring as the inverse or opposite of distributing. When you distribute, that means to multiply in, and when you factor, that means to divide out. So if we started with this expression, 5 times the quantity 2x plus 7, and distributed the 5, we would get 10x plus 35. But if I started with the expression 10x plus 35 and divided out 5, and kind of went backwards, then that would be factoring, and I would have sort of undistributed that 5. So in many ways, that is what factoring is all about. It's all about taking a polynomial that's in sort of an expanded form and rewriting it so that it's a product. And there are a lot of different uses, a lot of different times when taking a problem and writing it in a different way or looking at it from a different point of view is going to be really important and really helpful. It's kind of like Optimus Prime. There's times when he is a truck and there's times when he is a giant robot. So factoring polynomials, same exact thing really. First thing I want to take a look at is factoring specific numbers. So I want to start with an expression, 18x plus 24. And 18x and 24, they have some factors in common. So I want to take a look at factoring some things out. Well, what's something that goes into 18 that also goes into 24? Well, 2. So if we divide it out, 2, what I'm doing is I'm writing 2 outside of parentheses, like before it got distributed in. Well, what would be inside these parentheses if 2 got distributed in and it resulted in 18x plus 24? Well, the reverse of distributing in is dividing out. So 18x divided by 2 is 9x, and 24 divided by 2 is 12. So I've basically factored out a 2, and I've undistributed it. If you multiplied it back in, you would just come back to this same thing. Now that's not the only number that goes into 18 and 24. 3 goes into 18 and 24. So what if I divided out 3? Well, 18 divided by 3 is 6, so the first term would be 6x. And 24 divided by 3 would be 8. So if I factor out a 3, I get 3 times 6x plus 8. Well, what if I factored out a 6? Well, 18 divided by 6 is 3, so we'd have 3x. And then 24 divided by 6 is 4. So if you divide out a 6, you'd have 6 times the quantity 3x plus 4. So what I've done here is factored out a few different numbers and just rewrote this expression in some different forms. Now where we're going with this is we're going to want to factor out the greatest common factor, the largest factors that we can. So when I factored out 2, I didn't factor the greatest common factor, the GCF, because there's still something that divides 9 and 12. 3 is not the greatest common factor because there's still more that divides 6 and 8. But 6 is the greatest common factor because now there's no more integers that can be divided out of 3 or 4 other than 1. So let's take a look at an example of a polynomial and work on factoring out the greatest common factor. So here's a polynomial, 18x squared plus 6x plus 20. What I want to do is factor out the greatest common factor, the GCF, from this polynomial. So the first thing to do is figure out what that greatest common factor is. So here's what you should be thinking about. Take a look at all of the coefficients. Right now I have 18, 6, and 20. And ask yourself, what is the largest integer that can be divided out of both of those? Well, all of these are even, so that means 2 can definitely be divided out. And there isn't anything larger than that that can be divided out in this case. So the GCF is 2. And also you want to look at all the terms and look if there's a variable that they have in common. So these two have an x term or x factor, but this one does not. So since they don't all have an x factor, I can't factor out an x from there evenly. What I can do is factor out a 2, and so write out a 2. Whatever you're dividing out, write that on the outside of some parentheses, and then divide that factor from each of the terms. So 18x squared divided by 2 will be 9x squared. 6 divided by 2 is 3, so that'll be 3x. And then 20 divided by 2 is 10, and so that's 10. So what I've done is factor out the greatest common factor, which was 2. I've divided that factor out. Let's take a look at another example here. So here's a polynomial 9x to the 4th minus 6x to the 3rd plus 3x squared. So I want to take a look at what is the GCF of these three terms. Well, taking a look at the three coefficients, I can see that 3 will divide any of those three numbers. 9, 6, and 3, those are all divisible by 3. Also, in this case, we have each term has an x factor. So I want to know what's the largest number of x factors I can divide out of all three terms. Well, this one has 4, this one has 3, this one has 2, so the most that I can take from all of them is 2. So 3x squared is the greatest common factor. So I'm going to divide out 3x squared. So I'm going to start by writing that on the outside of some parentheses. Then I'm going to look at each term and divide that number, or divide that term by 3x squared. And you can do it step by step. So 9 divided by 3 is 3. And x to the 4th divided by x squared is going to give us x squared. We had 4 factors of x to begin with. We divided out 2 of them, so there are 2 left over. Next term, negative 6 divided by 3 is negative 2. And I had 3 factors of x and divided out 2 factors of x, so that's going to leave 1 left over. This last term, 3 divided by 3 is 1, and x squared divided by x squared is also 1. I had 2 factors of x, divided both of them out, so now this term has no factors of x. So this is the same polynomial, just in a different form. I have factored that down. So now this is rather than just 3 terms, it is written out in terms of a product. Let's take a look at one more that involves more than one variable within the polynomial. So let's say 20x squared y plus 14xy plus 20y. What I want to do is factor out the greatest common factor from that polynomial. So looking at all 3 of these coefficients, I can see that 2 divides each of them evenly, and that's the largest number that will divide each of them. So 2 is part of my greatest common factor. I see this one has an x squared, that one has an x, that one doesn't have an x factor. So I can't factor out an x from all of them evenly, but all of them do have a y. So 2y is the greatest common factor. Since I'm factoring that out, I'm going to write it on the outside of some parentheses. 20 divided by 2 is 10. X squared, I didn't divide out any x terms, so that's going to stay x squared. And y, I had 1 factor of y, and I divided that out, so I don't have any left inside the parentheses. 14 divided by 2 is 7. X didn't get divided out, but y did, so I just have that x. 20 divided by 2 is 10, and that y got divided out, so I don't have any variables on that anymore. So this factored to 2y times 10x squared plus 7x plus 10.